next we will be seeing how to establish these precedence relationships. So, the previous example that we have taken, so that is from our knowledge in our arithmetic classes. Okay. So, we know the precedence between the operators and accordingly we could make that table. But in general, given a language, so we have to establish precedence relations between the terminal symbols of the grammar. So, how to do that? So, we first construct two lists, one is known as first of plus, another is known as last of plus. So, first of plus is a list of terminals which can appear first on any right hand side of a production. So, you take any if you take any derivation from one particular non terminal symbol. So, you take any grammar rule. So, now you so what from the starting with that grammar rule, whatever terminal symbol can appear first on the right hand side. So, that will be called first of plus, and similarly last of plus. So, this is the list of terminals that can appear last on any right hand side of a production. So, that will be the last of plus. So, how to construct this last of plus and first of plus? So, before going to this last of plus first of plus, so we have to consider first of and last of. So, first of is like this. Suppose we have got a grammar rule which is say x producing a, etcetera, etcetera, where a whatever I am writing is in lowercase letter. So, they are terminal symbols, and whatever is written in uppercase. So, they are non-terminal symbol. So, in this particular rule I have got a as a terminal symbol. So, and this b is a non-terminal, c is a terminal, like that. So, what we do, you take from the rule the first terminal symbol that can come. So, the first of x. Okay, so, this has got a, capital B and C. So, what is the first operator or first symbol that can come, first to terminal symbol that can come on the right hand side derived from x. Okay. So, this is the definition of first of. Now, you see, if you follow, so from this rule we understand that I can get a string where the first character is a, first symbol is a, and from this rule it says, so whatever will be there in the first of b will be in the first of x. Okay. So, that is why we include b in the first of x, and later on when we convert it into first of plus. So, those replacements will be done. Similarly, from the for the last of, so if there is a rule like this, so y producing last symbol is a terminal symbol, and here the last symbol is v and w. So, this is in that case u, v and w will be putting in the last of y. Now, we compute first of plus and last of plus using the closure algorithm. So, closure algorithm is like this, that we take a non terminal and then so we can take them in any order. So, we order the non terminals in some fashion, take the first non terminal and look for it in all the first of lists. So, then you check whether that particular non terminal appears in the first of list of any other non terminal. So, if it happens to be so, then you add this first of symbol list to any other in which it occurs. So, like here if you know what is the first of list of b, then you can add that first of list of b to the first of list of x. So, this way we can compute the first of plus. Similarly, we can create the last of plus last of list. Okay. So, that will give us last of plus, and then from these two lists, so we drop all the non terminal symbols, because by the definition of first of plus and last of plus. So, there is no such non terminal symbols will not be there, only terminal. So, we drop all the non terminal symbols from there. So, let us take an example and see how this thing happens. Say I have got this grammar E producing E plus T or T, T producing T star F or F, F producing within bracket E or I D. So, first of E, if you go by this rule, it says E will be there, then this plus will be there, because this is a first terminal symbol that can come, and this is the T. From this rule I can get T. Similarly, from T star T producing T star F, I will get T and star, and from T producing F I will get F. So, that is the first of T, and first of F will be, it can be open bracket start or I D. So, open parenthesis and I D. So, these are the first of F. Similarly, if you try to see last stop of E, so it can last stop can be E plus or this T. So, this plus and T are in the last stop of E. Last stop T is star and F, and last stop of F is close parenthesis and ID. Then we have to consider we have to construct the first stop plus. So, first stop plus of E is it says that since T appeared. So, whatever is appearing in the first stop list of T. So, that should appear in the first stop list of E. So, apart from this E plus T, so we add this T star and F onto this, and then in the next round. So, since F appears, so whatever is in the first stop list of F, so that will appear in here. So, as a result, this open bracket, open parenthesis and ID, so they also appear in the first stop plus list of E. Similarly, we can construct the first stop plus of T, so which is T star F open parenthesis and ID, and first stop plus of F, which is open parenthesis and ID. Then similarly, we can construct the last stop plus list. So, last stop plus of E will be whatever is there plus and T, then whatever is there in the last stop of T. So, they will appear like star F, and from the F I will get this close parenthesis and ID. So, all of them will come. So, this way we can go on constructing the first stop plus and last stop plus for individual non terminals, and then from this list. So, you have to drop the non terminal symbol. So, this E, T, F are dropped. So, you get it like this. Similarly, if from this you get star open parenthesis and ID, here you get open parenthesis and ID. So, here also you get the corresponding last stop plus. So, once you have constructed this first stop plus and last stop plus for each of the non terminal symbols, so we can find out some precedence rule that can be used for getting an operator precedence parser for the language. So, this is the rule to construct the precedence matrix. So, it says that whenever a terminal A immediately precedes non terminal B in any production. So, if you have got something like this. So, A producing say A B. So, here this terminal A, sorry. So, this A producing say A B X, then what happens is that this A, or say instead of X, so I can write like alpha. So, any symbol, any string of, so alpha is any string of grammar symbols. Now, this B is a non terminal and A is a terminal. So, A is immediately preceding non terminal B in a production, then whatever you have in first stop plus of B. So, whatever you have got in first stop plus of B. So, let us make it some other symbol. So, gamma. So, first stop plus of list, suppose it contains the symbol alpha, then I have to make A less than alpha. Okay. Then it says that the second rule tells that if a terminal B immediately follows non terminal C. So, if you have got a rule like this, A producing something like say C, then B, something like this. Then you look into the last stop plus list of C, and wherever you have got any beta belonging to the last stop plus of B, last stop plus of C, make them to be higher precedence than B. So, by this rule I have to make this last stop plus and first stop plus, these two things. And if there is a sequence like this, so A B C or A C, where B is a non terminal, in that case we make the for any production, then we make them A and C to be of equal precedence. So, this is the third rule. And the fourth rule says that dollar, the end of string character, so that will have lower precedence than all terminals in the first stop plus and last stop plus list of the start symbol of the grammar. Similarly, it should be A should be greater than dollar for all terminals in the first stop plus and last stop plus list of S. So, you take the start symbol of the grammar, from there we get it. So, using these rules, so we can formulate the precedence matrix that can be used by the parser. So, let us see for the example that we are considering how they are going to occur. See, this is the first of class list for ETF, this is the last of class list for ETF. Now, let us consider this rule like E producing E plus T f, E plus say E producing E plus T. Then the first rule that we had, it says that if you have a rule where a terminal A precedes non-terminal B, immediately precedes non-terminal B. So, that way what qualifies is this plus. If we consider the first rule, so we have to see this plus and T. So, it says that the whatever you have got in the first of plus of T, the rule said that whatever you have in the first of plus of T, so this A should be of lower precedence than that. So, you see here, so plus is made to be lower precedence than this plus is to be made lower precedence than this star open parenthesis and ID. So, plus is made lower precedence than open parenthesis ID and star, fine. And similarly, if you come to this rule T producing T star f, then star should be of lower precedence than the first of plus of f. So, star is of lower precedence than open parenthesis and this ID. Then coming to this rule, so this open parenthesis and E, so open parenthesis should be of lower precedence than all the all the symbols in the first of plus of E. So, open parenthesis is of lower precedence than this one. So, this open parenthesis, so plus star open parenthesis and ID. So, plus star open parenthesis and ID. So, it is less than all of them. So, that finishes complete applying the first of rules. Now, with the last of rules, so what we will have? So, it says that if you have got a production like this, so E, so this production, so E producing E plus, so this E and this plus, so when you consider these two, then the rule said like this, that so this if you take the last of plus symbol beta, so beta should be of higher precedence than B. So, beta should be greater than B. So, here this E, so so plus star bracket close and ID, they should be of higher precedence than plus. So, plus is of higher precedence than plus is of higher precedence than plus, sorry. So, plus is of higher precedence than plus, plus is of higher precedence than star, sorry. So, star is of higher precedence than plus, because this is actually the set from where I am taking beta, and my rule is beta should be greater than B. So, beta is greater than plus here, similarly star is greater than plus here, then we have got close parenthesis. So, close parenthesis is higher than plus, and ID is also greater than plus. So, all the greater thans I have taken care of. So, this way we can do all these things. So, for similarly last of plus of T. So, from the second rule I will get this T and star, okay. Getting this T and star. Now, last of plus of this thing has got this star close parenthesis and ID. So, this so I should, if this is the set beta, from here I am taking beta. So, beta should be greater than star. So, that should be the thing. So, star should be greater than star. So, that is done here. Star should be greater than close parenthesis, star should be greater than close parenthesis, done here. Then star should be greater than ID. So, so ID should be greater than star. So, ID should be greater than star. So, ID is greater than star. So, that way it is getting the thing. So, we can see that we can formulate this first of plus and last of plus, and from there we can make this table. Now, this particular rule this particular, so F producing within bracket E. So, this is of the form that A, B, C, and then it says that A and C should have equal precedence. So, this open parenthesis and close parenthesis, so that is of equal precedence, but it does not mean that close parenthesis. So, this particular entry, so this should also be equality. So, that is not true. Okay. It should be like the situation is like this. So, if there is open parenthesis, there will be a matching close parenthesis, but there cannot be an expression which is like this. Okay. So, this is actually excluding that. So, if you get an open parenthesis, so in this region, so you can get an expression, but here there is a problem. So, there must be some operator in between that should come. So, they are there. So, whatever entries are not defined, so they are all errors. So, this is error. So, this is also error. So, all these entries that are undefined, so they are all error entries. So, if you come to this error entry, that means there is some problem with the input string. So, that has to be discarded. So, next we will be taking an example, another example for which we will be constructing the this operator precedence table and operator precedence, how this operator precedence table will work, parsing will work. We will take an example. Suppose let us take an example grammar which is like this. So, S producing within bracket L or A, then L producing L comma S or S. So, this is the grammar that we have. Now, so first we have to consider the first stop of this S and L, first stop of S and first stop of L. So, first stop of S, so this has got open parenthesis and A. Similarly, first stop of L, it has got L. I will not write these commas because that will confuse with the comma that we have there. So, I will not be writing these commas. So, let us delete these commas. Okay. So, let us delete these commas. So, I will be as whenever I am writing separated by a space, that means that is the next thing, that next character that I am writing. So, this has got L, then comma, okay, and S. From this rule L producing S, I will have this thing. Similarly, I can write the last stop of S to be equal to A and close parenthesis, and this last stop of L can be made equal to comma and S. Last stop of L is comma and S. So, from this I have to construct the first stop plus and last stop plus. So, first stop plus of S will be equal to, so it does not have any non terminal. So, this is the list first stop plus of S and first stop plus of L So, this has got L comma S. So, since S is there, so this bracket start A they will come and the comma will come. So, this is the first stop plus of L. Similarly, last stop of S will be equal to A and close parenthesis and last stop plus. So, this is last stop plus of S and last stop plus of L will be equal to comma, then last stop of S will come, that is A and close parenthesis. So, they will come. So, this is the first stop plus and last stop plus rule. Now, based on that we can make the parsing table. the precedence table. So, we can make the precedence table which will be like this. So, we write down the terminals dollar open parenthesis close parenthesis a and comma, and this side also we have got dollar open parenthesis close parenthesis a and comma. So, if I have to fill up this individual entries here, okay. Now, if we apply the rule first rule, so we have got open parenthesis L. So, this first first one it says open parenthesis L. So, whatever you have in the first of plus of L, so A should be the, so open parenthesis should be less than first of L. Okay. So, first of plus of L has got open parenthesis A and comma. So, open parenthesis should be less than open parenthesis, sorry. So, open parenthesis should be less than open parenthesis, then we should get this thing this less. So, first of L has got comma. So, comma should be less than open parenthesis, this A should be this open parenthesis should be less than comma. So, open parenthesis is less than comma, open parenthesis is less than comma. So, these two are done, these two are done because this is L. So, open and A. So, open parenthesis should be less than A. So, the other entry is this one open parenthesis less than A. Similarly, we have to get the next one. So, this L producing L comma S. So, between this comma and S, so comma comes before S. So, this comma should be less than first stop of S. So, first stop of S, first stop plus of S has got open parenthesis and A. So, comma should be less than open parenthesis, comma is less than open parenthesis and comma is less than A, comma should be less than A. So, this should this way I can do this. Now, this equality, this two open parenthesis and close parenthesis coming in this rule S producing L within bracket L. So, that will make this open parenthesis close parenthesis to be of equal precedence. So, that will be done like that, and the rest of the entries like say we have to have this rule, say L close parenthesis. So, this L close parenthesis. So, this will tell that this last stop of L, this should be of higher precedence than close. So, last stop L, last stop plus of L has got comma and A. So, comma should be higher precedence than bracket close, comma should be of higher precedence than bracket close, and this A should be of higher precedence than bracket close, and this bracket close should be of higher precedence than bracket close. And then we have got this rule, say comma S. So, from this second rule comma S. So, this for last of S, it should be greater than comma. So, last of S, last of plus of S has got A and close parenthesis. So, A should be of higher precedence than comma, A should be of higher precedence than comma, and close parenthesis should have higher precedence than comma. So, this is the other rule that we have. Now, this one L comma. So, L comma. So, this will tell us that this comma. So, last stop of L, this should be of higher precedence than comma. So, last stop of L has got comma. So, comma should be of higher precedence than comma, should be of higher precedence than comma, then comma should be of higher precedence than comma, then this last stop of L. So, this has got A should be of higher precedence than comma. So, that is already done. Then close parenthesis should have higher precedence than comma. So, that is also already done. Now, for the dollar part, so it says that since S is the start symbol of the grammar, so dollar should be less than the open parenthesis. So, you have to see the start first of plus of S. So, that is open parenthesis and A. So, there I should have this relation, and for the last of plus of S I have got A and close parenthesis. So, I should have A to be of higher precedence than dollar and close parenthesis to be of higher precedence than dollar. So, using these rules, so we can formulate this table, and we can use this parsing table now for doing the operator precedence parsing.